let's work on the magnitude activity. So I've already got my new script written and I've got my interpreter in the proper location. So let's have a quick look at what the activity requires. Write a function, CompMag, takes two parameters, r and m, to compute and return the magnitude of a complex number. It should take the real component as parameter r and the imaginary component as m. So just remember that. That just means the magnitude of the complex number is equal to, my math formatting didn't quite work here, but all this means is the square root of r squared plus m squared. Okay, so I've got two problems. How the heck do I do exponents in Python? And how do I do square root in Python? Well, let's ask Google. How do you do in Python? I've got high hopes for this one. Okay, how do I do square root? Well, I'll need that, so let's hit pause on that. And how do I do exponents in Python? Let's start with exponents. So this guy's asking, how do you cube something? So that's the XOR operator, whatever that means. And star star is exponent. Okay, so 2 star star 3, or 2 to the power 3, is 8. Checks out. And now square root. Oh, right. If you remember your math, square root is just something to the power of a half. So we can just power something to the half to make it work. So let's go right to our script here and start writing. So def CompMag rm colon indent return. So how are we going to do this? So we need r2 plus m2, and then we need the square root of all of that. So to 0.5, and let's test it. Print out CompMag, and let's give it 5 and 5. Okay, let's have a quick look here. Run 3.4.py. Let's take its word for it that the magnitude of that complex number is 7.07. So that's cool, but you know, you might not like the half exponent thing, like to the power of a half. And that's cool. That's fine if you don't. I don't really like it either. So we can actually do something different. If we go back to what that website was saying, it says we could do something called math.sqrt. So let's go back to our script and type that in instead, because it might be a little easier to read. So math.sqrt. Put that all in brackets and get rid of this power to the half. So we're calling the function sqrt. It's a math function. And let's hit run. What? We got some sort of error here. Global name math is not defined. Here's the thing. There's a function called sqrt written somewhere on your computer, but it's not in this script here. It's not in the script 3.4. I didn't write it. We need to tell Python where it is, and it's actually in a file called the math file. So I need to import math. I need to tell Python, hey, there's some functions I'm going to need that are written in the math file somewhere on the computer. So if I do this and I hit run, it should work. Ah, it did. That's cool. So that's an import statement. There's another way to do an import statement too. It goes like this. I'm going to say from math import star. So what this means is from the math module, the math file, import everything. And when I do that, I don't actually need to write math dot square root. I can just say sqrt. Because when I write from math import star, that basically means take everything from that math module, that math file on the computer, and pretend it's in this script that I'm working in right now, the 3.4.py script. So if I say run now, this should also work. Cool, it does. But be warned about doing imports like this. I personally prefer it the other way, where I say import math. And the reason for this is there can be conflicting names. For example, there's a sqrt function in the math module, and there's also an sqrt function in the numpy module, which we haven't learned about yet, but we will. So if I wrote from numpy import star, there's an sqrt function in both of these modules, in both these files. How does the computer know which one you want? Do you want the one from the math or the numpy? What do? If we did it the other way, import math and import numpy, I would have to write math.sqrt if I wanted the math one, and I would need to write numpy.sqrt if I wanted the one from numpy. So this just makes it so you have to be more explicit. It's a little safer. Both will work. I personally like doing it this way. And we call this here the namespace. So from the numpy namespace, call sqrt. And if I had math, from the math namespace, call sqrt.